Okay, so let's come back to it. I've got some great news. We don't really have to know how pointers interact with basic types to do much with them. We do have to know how basic types work, but luckily we're going to be spared using pointers directly like that to basic types. However, I know I'm sorry. However, all the objects that we get from Objective-C are going to be accessed using pointers. Here's the thing about Objective-C. Objective-C is actually kind of like Swift in that Apple owns it. Apple doesn't own Swift, but they created Swift and then they open sourced it. Objective-C used to just be some language that, I don't know, no one really used. Then Apple bought it. And they built out this framework that we're using that let us be object-oriented. And by this framework, I mean Foundation. So here is the thing about Foundation. We go and we look into its header file. Amazing. It imports a whole bunch of stuff for us. What do you see is in common with most of the header files in this header file for Foundation? What is in common in terms of naming for most of the header files in this header file that imports Foundation? I heard it in the back. Naming. There's a .h, yes, that means a header. That means we're going to get the interface from these other files. But I also heard there's this ns prefix with most of those header files. ns. So we have seen ns before. Does some stuff, that's cool. Foundation is going to import the major NS objects for us. Does anyone remember what this NS stands for? Not safe could mean something, but in this context, NS stands for next step. Who really cares what next step was? It's gone. I'm so sorry. But it was also part of Apple. That was another company they purchased, then put together, and who really cares? But what we have this NS prefix for is it's going to create a whole bunch of objects for us. Phoenix.
Just a general question, is that like common in the code in general, just taking like Zavi code from past companies and stuff, just implementing it in whatever you create?
Not really, actually. That's a good question. Do companies typically buy other languages and steal their code? Not really. Apple's very, what's a nice way to say, industrially paranoid. So they bought Objective-C so that those first apps that were built, well, they bought Objective-C way beforehand, but they said, oh, we own this language. All the apps that we make are going to be built in this language. They later decided maybe this wasn't a great idea, and then they started creating Swift. But it's okay. Objective-C was what was available at the time. So what we're going to do with all these NS types, we create objects from all of these types. We're going to see that just like there's inheritance for all the types that we've used in UIKit, there is this base object that we get from Foundation. Base object is called NSObject. Very, very creative. So let's go take a look at NSObject. NSObject. The root class of most Objective-C class hierarchies, from which subclasses inherit a basic interface to the runtime system and ability to behave as Objective-C objects. Hurts, but what do we think this means? Yep, okay, I already said that. The root class. Albert, Objective-C is an object-oriented programming language. Yep. So what do you think a root class for an object-oriented programming language means? It's a tree. It could be kind of like a tree. But what does it mean in terms of object-oriented programming? Okay. Sunny. Sorry. It's a parent class for all other objects. Cool. Alex?
Then I'm feeding off that like the ancestor, or like everything will be inheriting functionality from that object.
Cool. It's like a parent, like an ancestor. I agree. It's the parent or ancestor at the root, I guess that's why they call it that, of class hierarchies for Objective-C objects. Let's look again at that because it literally does some stuff we've never even considered before. Subclasses inherit a basic interface to the runtime system and ability to behave as Objective-C objects. So if I define an object that doesn't inherit from NSObject, I don't have the ability to actually run the program into the program this object. I also don't have the ability to treat that object as an Objective-C object. There are certain things that are just built into NSObject that, sure, we could look at if you really want to, but we don't have to, that are going to interpret our objects and let us do things like give them properties. Let us do things like define methods for them. So when we start creating our own classes next week, we're going to see that pretty much everything is going to inherit from this NSObject. And that's so that we can literally just use things as classes. That stuff is not built into something like using a keyword class. So we need this to create and use custom objects. All right. Let's try to do some Swift stuff. Let's try to make an NSObject. We're used to that, right? So how do I start declaring something in Objective-C? I need the type. So what would the type of an NSObject be? Thank you. So I want to start by making an NSObject. Cool. Now what do I do? I'm going to name it. Okay, I'll call it object. How do we feel about that? Not specific enough? Oh, my. Who said my? All right, we have this object. All right, let's see. Can I do this? Well, I'm going to need that. Oh, let's run this. Ah, damn it. Interface type cannot be statically allocated. Insert this thing. Oh, that's right. All my objects are going to have pointers. Okay, that's a good first step. All of my objects are going to have pointers. If we want to get really crazy and see actually what that error meant, this interfacing to a type, right? What NS is doing, what this NS object is doing is letting us interface to something in Foundation called NS object, to only those things that were exposed to us, like we saw in header files the other day. We'll talk more about this when we make our own types, but it's saying the interface to this thing that we're inheriting from can't be statically allocated. And what that means is our programs are meant to create these objects when the program is running. What we're trying to do right now is we're trying to create these objects at the time that it compiles. This is a weird thing that we have to deal with, but every object is going to have this pointer notation so that our program creates and uses that object at runtime. We're not creating instances when we compile like we did above with that basic type int. So in order to use our objects from Foundation, we got to do it like this. It's so wonderful, I know. But we can't initialize like we're used to in Swift. Unnamed interface name, NS object, expected expression. This is not the syntax for creating a new object. Bless you. Let's talk about how we create objects in Swift. Can I do this? Let's say I've got an NS object that I can use in Swift. Var Liana's object is an NS object. Can I do this? Really? Have you ever created a class but not wanted to give it an initial value, or a struct and not wanted to give it an initial value? What? So this isn't optional. No, this isn't optional. What this is a little different. Let's open a Swift playground and look at it. My P. So let's say Liana's got a string instead. Var Liana's string. It's going to be a string. All right, let's run this. Run, run, run. These computers work really well. This line does work. It doesn't do anything. It doesn't even store a value. But what it's doing is declaring a variable without initializing it with a value. Initializing it with a value.
Kind of like empty parens then?
No, so empty parens is actually giving it a value as an empty.
Empty quotes, sorry.
Still, even that, what you're doing is creating a string with the value empty string.
Okay, got it.
This is just what we call
This object exists.
allocating space to the object.
This happens at compile time.
This happens at runtime. The way we can do this same thing is we can say, all right, using whatever you do with that class NS object, there's this wonderful, let's look at that keyword again, ALLOC, alloc. It's amazing. Returns a new instance of the receiving class. So what we're doing is creating a variable just like in Swift, in this line, but what we are not doing to it is giving it any initial value. Instead, we're just saying there should be a pointer to some address that I can reference by using the name Liana's object. What's that? It is hot. Amazing. All right. Now, let's say I want to do this. Var Liana's object, which is an NS object, is equal to NS object. And open and close parens. Seen that before. Jocelyn, what does this open and close parens for like pretty much any type we've seen do? Sorry? Making an instance, cool. So if I were to do this whole line, what does Liana's object store? Let's say it was like this. What do I have there? Sorry? Yeah, what would that string's value be? Okay. So this string's value would be the same thing as an empty string. What we're doing is we are initializing a string with the Swift just empty initializer. We're not initializing with a value, and that's defined as creating an empty string. We're initializing that string and then assigning it a value. Let's clean that up because this is a string now. The way we can do that is, you're going to see this all the time, and it's a really fun language feature. If you remember, we said these square brackets are going to be the way that we call methods. Going back to Tuesday, what did we say calling methods actually, how do we actually talk about calling methods? We don't actually call methods on objects. Instead, we do something different. Yeah. So I mentioned on Chuck. I mentioned on Tuesday that actually the way that people talk about doing stuff to objects is not calling methods. We call it something different. We're sending a message. So this is the format for sending a message. The message we are sending is allocate some space for an NS object. And then you will see this all the time. To actually initialize an empty object, you will allocate some space, and then you will initialize a value into it. Then why am I getting this error just from my Objective-C experts here? Amazing. You need a semicolon at the end of every line. That is an expression. So I have initialized an empty NS object after I've allocated the space to it. I can't just do what we see in line 77, where with type inference, my Swift compiler knows that I want an empty string here. Instead, I create an NS object. Oh well. That's okay though. Foundation is going to do a lot of this work for us if we just understand how to create objects for ourselves. Phoenix.
Do the brackets not work when how they work in Swift? Or without being like an array of arrays in something?
So arrays actually work a little differently. If we used a basic type array, just like the argv we saw above, whee, right there, I would have to say I want an array of ints, which is an array, and I want it to equal 1, 2, 3, and 4, or something like that. This is the syntax for a basic array. That stuff sucks. That's right. This sucks. It does, I promise. Well, we can't call any methods on that thing. We can't really do anything with it. We can make it do whatever we want. Okay. Well, Foundation's going to let us do more advanced things with arrays. So for example, there's this thing called an NS array. That is an object type that we can initialize that has certain messages built into it that we can send to it.
Messages meaning functions.
Mm-hmm. Messages, yep, kind of just meaning instance methods. So what Foundation's doing for us is giving us basic types that are objects rather than like just some built-in thing, and letting us call functions on those things. First one I want to look at, because it's actually like pretty important for how Foundation works, there's this thing called an NS number, an object wrapper for primitive scalar numeric values. Object wrapper for primitive, oh, look at it again, scalar numeric values. We've used the term wrapper before. Anthony, can you give me like a decent definition for a wrapper? So what have you done with a thing like a struct to create a wrapper? Yeah, so it like encapsulates other objects. Cool. More generally, what this is going to do is it's kind of just going to create a box around those basic number types that exist in Objective-C. So we saw an int, there's also a float, there are long ints, stuff like that. But this is a, like, when we talk about an object wrapper, it's taking away you needing to know what exists under the surface until you need to use it in a way that it mutates. Let me say that again. By wrapping up the primitive numeric values, so things like an int or a float, by wrapping that up, it's going to let you use this as an object, do a bunch of stuff to it until you need to actually transform the underlying primitive numeric value. So an NS number is, yeah, it's like an int, but in Swift, ints have instance methods. In Objective-C, that lowercase I int doesn't have an instance method. That stinks. So instead, we'll create NS numbers that have inside of them ints or floats or whatever you want it to be, and then we can do stuff with it. We can compare, we can add it to arrays, we can do all this stuff. What this object wrapper thing is an example of is something called boxing. So we're boxing some values to allow us to have behavior with those values. So let's look at an NS number. NS number is an object. So what syntax must be present in the naming of this variable? How do I start naming this thing? Yep, asterisk. My first number. All right. So in order to initialize, I could do something like I did above, where I take an NS number, allocate some space to it, and then I initialize a value in there. I could do this just like above. Albert, what's this error for? I'm sorry? Say that again? What does that red arrow I'm seeing on the side probably mean? So I need a semicolon at the end of every expression. Thank you, Albert. That's great. Let's print this out. Crystal, what's the function that I use to print in Objective-C? Sorry? Yeah, let's do it. So let's nslog. I don't want to print out this number. Oh man, this line's not going to work for a number of reasons. I want to see my first number. Okay, my first number. Neat. Eric W., I'm going to see some errors here. In order to log this, what do I need to make happen? So can I do this? Yeah. Cool. So every time I create a string literal, I need that @ sign. Thank you. I see some other errors though. Expected. Let's write a semicolon. Okay. I no longer see any errors, but is this going to print out my first number? Phoenix. That's right. It's literally going to print out / my first number. There's no string interpolation. It sucks. So instead, what we're going to have to do is use that % sign to format in some value, and then add as the first argument my first number. This % sign needs to flag a certain type that it expects. My first number is an NS number, which is an object. What should I use to indicate an object? We're going to use an @ sign for our objects in order to print out what that object is. You'll use the string formatter @. All right. So my first number is null. That stinks. But would you expect that? Yeah, we didn't initialize it with a value. Dang. Null right now. So the nice thing again about our objects that we get from Foundation is that they have initializers just like the ones we're used to with objects that we use. So I'm going to make a new my first number, and I'm going to call a different kind of initializer. Let's see. Let's poke around. Go and look at the documentation for an NS number. I see a bunch of things here. Init with coder, init with car, init with unsigned, init with int, init with long, init with long, init with float double. So if you look at all of these, here's what you're going to see. NS number, again, is not just an int. It can hold, it can be the wrapper around a bunch of different types. So I can init it with an int. With int. Number with int, number with integer, slightly different. Number with unsigned integer. Okay, that sounds nice. Let's make an int. Nima, what's your favorite number? Nima, when I print this out, what do you expect to see?
We have an error.
What's the error? Yes. Thank you. When I print this out, what do I expect to see now?
I want to see my first number 7.
Cool. Let's check it out. Awesome. I want to see my first number 7. Great. So I've got my first number right here. It happens to have an int in it. This object knows how to interpret it, kind of like using a custom string convertible in Swift and looking at string.description. What's built into NSNumber is the way that it should format the printing. Liana.
Why didn't you have to allocate space for it?
Why didn't I have to allocate space for it? That's a great question. Creates and returns an NSNumber object containing a given value. So it's actually going to handle all of that for us. That's the nice thing about these objects is that the default NS object makes us allocate an init space, but these children or these subclasses of that NS object, so something like NSNumber, have their own inits that they use to allocate and then initialize with values instances of their own type. So any object that inherits from NS object can allocate and init space to itself. But chances are those subclasses of NS object are going to have their own initializers that are a little more helpful. All right, let's make some more numbers. Gotta make this whole NSNumber thing. Ah, man. My second number is an object of type NSNumber, which is going to be, I don't know, I want to make it a float. Okay. So I've got a number, float. Oh man, I need a semicolon. Great. I can make another NSNumber. Check this out. My third number, which is an NSNumber with, I don't know, what's someone else's like favorite number type? Amazing. I like doubles too. Let's make a number with a double. I'm going to make that double twice as much as the float, just as sort of a joke for me. All right, so I've got some numbers. Let's see what happens when I print them out. My second number, my third number. All right, there are my numbers. That's great. This one shows up as an int, this shows up as a decimal, I'm assuming it's a float, this one shows up as a double. But NSNumber is actually going to let us use those numbers that it wraps up as pretty much any of those types. So let's say, for example, I want to say this, my second number, which is a float, how can I print this as an int? Because again, these NS numbers, they're objects, right? We've got instance methods, and the whole point of this NS number is to wrap up some basic number types and allow us to call functions on them. But the type of my first number, my second number, and my third number is still NSNumber. So if that's the case, NSNumber should allow me to use the number that it encapsulates as any of the types that it can be initialized as. I should be able to use my second number and my third number as an int. I should be able to use my first and my second number as a double, so on, etc. So take 3 minutes and figure out how I can call a method or really send a message to my second number such that it prints as an int. Print my second number, which has the primitive value, the basic value 1.2 as an int. Slack it to me. Let's take one more minute. Do, 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 do. Okay, can I get a volunteer? Because I know it's a lot of code. These definitions make it really, really hard to use these objects in the ways we want, I think. Ayula, am I wrong? Am I wrong that having a wrapper around basic number types actually makes it harder to use a number, or does it make it easier? Oh, okay. Interesting. Tell me more. How could I do that with my second number? Like that? All right, let's see if it works. So now that this is of type int, print it with that D. I don't think that's what we're looking for. So we're not going to try to, what this actually is typecasting my second number. But there's something built into Foundation that's just going to make it easier. Sunny? Okay. Cool. The number object's value expressed as an int, converted as necessary. So when we talk about this NS number thing being a wrapper, it's doing the work for us of looking at the type that it's holding, that basic type, and then returning it to us in the way that we request here. By default, it'll give us the way we initialized it, but we can use this to kind of cast it. So any value that can be saved as an NS number, whether it's an int, float, double, can be provided to us as any of those types, an int, float, double, for example. So now let's see what we got. Cool. What do we notice when we look at second number as an int? What value do we get back? Cool. What if I change this to 6? Jocelyn, what do you expect to happen if I change this to 6? I'm sorry?
It's going to round up.
It's going to round up? Okay, let's see. It's still 1. Interesting. If I make it like 1.9999. Still 1. So just like we see with dividing ints and losing the remainder, if I try to convert a float or a double into an int, it's just going to drop the decimal. This is kind of the standard way that computers work. How would we get that remainder of that division?
Is there another property?
We could do that. Just thinking generally, if this is performing
Is there an int value?
if this divides, how could we get the remainder? Here's a special symbol. So there's got to be a way for us to capture that remainder. That'll be a fun part of your lab later. Amazing. All right. So here's the last thing I want to do. Some people, when we briefly looked at this array, said, this looks fine to me. I have a different opinion that I've put on line 63. Because what we can do, again, using Foundation is, we can create something called an NS array. It's an object, so I have to start with this pointer syntax. And make my first array, which is an NS array. Let's see, let's look at an NS array. Check its definition. Init with objects, init with coder. What do you think, which of these would we like to start with? Say I want to get all my NS numbers into an NS array. Yep. Init with objects. Cool. Now I just want to put my numbers in there. So I'm going to say my first number, my second number, my third number. Need one of those. Let's see if this works. Oh no. Expected to have one argument, not 3. Oh man, so I can't just do this thing where I list them? How else do you think we could do this? If it just wants to have one argument. We could create objects. Yeah, let's just put it in parentheses. So now it's just one argument. Cool. Let's print out this object. Goodbye, a second number as an int. Print out my first array. First array. Let's see what we get. Interesting. So I printed out my first array, and when I printed it, gave me 2.4. Huh. Where's 2.4? Yeah, my last number, my array.
Does the array have to be all the same type?
Does the array have to be all the same type? Let's take a look. So we do need a certain object type that are our objects. Let's go with yes for now, but we could always have NS objects in here, sort of use it like an any. That's fine. But here's the thing, I think that if I want to go and look at some property of my first array, maybe something like count, uh-oh, I get a crash. Interesting. There's this thing called an NSU integer. Should not be used as a format argument. Place it with this. Uh-oh, there's a different formatter for this thing. I know, it's amazing. So, two things that we should take from this. This count comes back as an NSU integer. It's an unsigned integer that is wrapping up some unsigned int basic type. And there's a specific formatter for that. And the reason I bring this up is because you're going to see NS integer and NS number all the time. NS number is an object that you can use to do a whole bunch of stuff. But NS integer is just a wrapper around the different int things. So if you can avoid it, don't use NS integers. But also, what we printed out was my first array had a count of 1, which means that this argument didn't give us 3 things. It only gave us 1 thing. So let's see if there's a way that we can find the syntax to initialize an array with 3 objects. Putting them in paren just returned 1 object. Take 3 minutes, and Albert, I'm going to ask you if you can help me do this. Albert, what do you got?
You want to initialize it with video down on three.
I'm sorry?
Video down on 5 and 3.
We didn't. That's what you're supposed to figure out. Can someone help Albert out? Sunny? Really? Damn. All right, let's see our count now. What's that? Uh-oh. Like that? What does that nil mean? They have nil in this language too? I'm losing it. It's scary. Okay. Let's look at the actual definition of this instance method. Arrays with objects. I should add as many arguments as I need, and it'll know to stop adding things when it gets to nil. That's what this syntax is. I can add as many things as I need to this array, and then when it sees nil, it says no more arguments are coming, which means that my array is only 2 items long if I put the nil before my third number, and so on and so forth. Get it? That makes sense. All right. Here's going to be our wrap-up task. It has to do with this word called mutability. Wrap up. Create an array that allows me to remove the last item. Let's say an array with 5 NS numbers in it. Okay, take until 12:15 for this. JK. Oh boy. Okay, Kimball. Hey, Kimball.
Maybe NS array to NS mutable array.
Oh. A dynamic ordered collection of objects. Interesting. A static ordered collection of objects is our NS array. Interesting. So if we want to use these data structures and then change them, we want to have mutating functions or mutate our objects. Most of them are going to have that mutable word in there so that they can be dynamically ordered. They can have their order changed. They can be mutated. So let's make an NS immutable array. How should we do that, Kimball? Okay. Mutable seems like a good start. Let's use NS mutable. We could do that. But here's a thought. Most subclasses of NSObject are going to have their own initializers that make it easier for us. So I'm going to pass to Eric M. I'm going to ask, did you find any initializers that might make this easy for us? Array with objects? What did you say? I'm sorry. Array with array. Okay. So I'll insert an array here. All right. It's not quite what I want to do here. I've got these 5 NS numbers that I want to use. If I want to make an NS mutable array, I will probably start my initializer with NS mutable array. And then what function could I use to actually initialize this? Rod. That sounds good. Let's use an array with objects. And again, this syntax is telling us add as many things as you like before this argument called nil, and I'll just add them all in if you'll let me. So let's add my firsts, or they're hours now. Our first number, our second number, our third number, our fourth number, and our fifth number. Amazing. What do I need at the end of this statement? Yeah, I need a semicolon. Dang. All right. If I print this out, if I use this string literal, and then I print our mutable array has this many items in it with a formatter for an object, bless you. What was that? You L me? Okay. Yes. So when I go to get my NS mutable array called Kimball's array, and I go and look at its count, it gives me this thing called count. Let's look at it one more time. It's an unsigned integer. That unsigned integer gets formatted into our string using this LU. Yuck. All right, it's got 5 items in it. That's great. I want to mutate this. Levi, can you take us home by helping me remove the last thing from Kimball's array? I could do that too. That's true. But we know all these documentation things too. All right. I'm looking at the interface. Amazing. For an NS mutable array. You can let me add an object. I can insert an object, an interest. I could, in index, I could remove the last object. Let's see if that works. Kimball's array, remove last object, removes the last object. Removes the object with the highest valued index in the array. I hope that works. So if this works, what should I expect to log on this last line? Yep, our mutable array has this many items in it. I should see 4. I hope this works. Let's find out. Wow, amazing. Amazing. What happened? Oh, that's right. I sent a message to this object saying, remove the last object inside of you. Think of an NS array and an NS mutable array, and pretty much any collection as a wrapper for other types, in the same way that an NS number is a wrapper for other types. We took this for granted in Swift. We can also take it for granted here. Anything inside of an array, we can just use as an array item. Conceptually, that's the same as using any value of an NS number wrapped up by that NS number. We can always do whatever is defined as part of its interface to do something. So for an array, I can remove the last object. For an array, I can initialize it with objects. For an NS number, I can initialize it with a variety of different kinds of numbers. And in the same way, I can initialize an array with a variety of different types of objects. So an NS array, an NS mutable array, is a wrapper around a group of other objects in the typical array format that we're used to, with indices, with the ability to reference items by their indices. And of course, the difference between an NS array and an NS mutable array is in the definition, but Liana, can you tell me what that difference is? An NS array and an NS mutable array. Yeah, we can actually change our mutable array. We can mutate it. We can. Mhm. Mm-hmm. Just like in Swift, they can have all different types. A Swift array takes a generic. We don't have quite that format here, but an array can take in what it calls, if we go and look at its definition, an object type. You can think of it like an array of any, in the same way that you can think of your arrays in Swift as arrays taking any one type. Object type. Check this out. What is object type? Oh, it's not defined. What do you think of an object type, just like we talked about yesterday, is? Yes, this object type is generic. An NS array can take in any type. Wow, yay. Okay. What are some questions you have about this wonderful language called Objective-C? Oh, so much. Soon we'll make apps with it, and it'll be much better than just making objects. Next time we will make some classes, give them some behavior, learn a little bit about what's under the hood of an object. There's something called an ID, by which we reference all objects. So next time, yay! Next time, we make our own objects. We learn about inheriting from the root class. Phoenix, what was that root class? Yeah, there's a root class from which we said all these objects that we create are going to inherit from. That does some basic stuff. Yeah, we'll inherit from NS object. So we'll get its properties. We will get the ability to send the messages it sends. And we learn about setting up interface and implementation parts of our code. Albert, what's that? What about UIKit? Let's see. So we are importing foundation as a header file, just like we do in Swift. Let's import. That's not how you spell it. I don't see UIKit, but maybe there's UIKit somewhere else. Is it in Foundation? No. Is it in something called UIKit? UIKit? Seems not to be there. How are we going to get it? let's save this for next time so that we can talk about where those interfaces come from and how you actually read this .h in. But UIKit works exactly the same. We still have view controllers, we still have table views, we still have these cool things. All right. Yay. File structures. Oh well. All right. Thank you.